All right, so this one says dy, is it dx or dt? Dy dx equals 4y. So remember, this is the equation. I'll use x since they use x there as well. Dy dx equals k times y for our exponential growth or decay. So the k value for this one is 4. So k equals 4 for this. And then they also tell us if y is 4 when x is 0. So that's our initial condition. Remember, that was our c value. So that's telling us that c is 4. So it's kind of weird because they're both 4. But this is our equation. And we're going to put in 4 for our initial condition, so c, and 4 also for that rate k. So they both were 4, which again is kind of strange. But there's your equation. So y equals 4e to the 4t. Or I'm so used to putting t. They used x. 4e to the 4x. That one's a. The other thing you can do is actually just work out the differential equation. You can divide over the y, multiply over the x, do the antiderivatives, work it all out. But if you know these two pieces of information, then you can get it a lot faster. All right, number 2, a puppy weighs 2 pounds when it's born. So that's the initial condition, and 3.5 pounds 2 months later. So again, here's our equation. 2 pounds is going to be that initial condition. So 2 for C. 3.5 pounds, that's the amount. So 3.5 goes in for Y, and 2 months later. So 2 gets put in for the time. So you're really just plugging everything in, and then we're going to solve K. So we divide over the 2. And then ln both sides. And then we're going to divide by 2. So let me pull out the calculator here. And we are going to type in ln of 3.5 divided by 2, close parenthesis. And then we're going to divide over this 2. So that is our k value, 0.279. I'm going to store that. So again, it's store alpha A, enter. So 0.279. I've got that stored. And then they're asking us, how much does the puppy weigh when it's 3 months old? So we're going to go back to the original equation and plug in 3 for time. We want the weight at 3 months. So again, it weighed 2 pounds initially. So 2 is still C. E to the power 0.279 times 3. And that is what we will type in. So 2 e to the power, now you want to do your stored value, and then times 3. So the puppy weighs 4.630. I think they rounded to 1 decimal point though. 4.6 pounds. So that one is B. All right, number 3, a population Y grows according to this model. So that tells you this is exponential growth. K is a constant, time is in years. The population doubles every 10 years. So this is a doubling time. So again, here's our equation. They didn't tell us what we start with, and they didn't tell us what we end up with. But if it's a doubling time, if I divide this C over, I'm going to get 2. Whatever you started with, if you doubled it, when you divide this over, you're going to get 2. So they don't actually have to tell you those numbers. If it's a doubling time, that's going to be 2. Equals E to the K times 10. They said the doubling time was 10 years. And it just says find the value of K. So, so once we find K, we're done. We don't have to like plug it back in or do anything else. We're going to ln both sides and then divide by 10. So I'm going to type in ln of 2 divide by 10. And so that is our K value, 0.069. And so that one is A. All right, number 4, bacteria in a certain culture increase at a rate proportional to the number present. So that's that sentence that just means we're going to have exponential growth. So there's our equation. The number of bacteria doubles. This is another doubling time. So again, if we don't know what we start with, but when we divide this over, we're going to get 2 if it's a doubling time. Doubles in 3 hours. So I'm going to plug in 3 for the time. And then we're going to solve this. Now this one, they actually just left these with the LNs in them. So I'm not going to use the calculator for this one. try and zoom in. Again, if you want to open this homework assignment in another tab so you can see those a little better, I know it's kind of small. All right, so we just won't use the calculators. This will be ln of 2 equals 3k. And when we divide over that 3, we'll just leave it like that, which is actually less work in a way because you don't have to type it in. It just looks a little messier when you're writing it. Right, so the question is, in how many hours will the number of bacteria triple? All right, so if we want to know when the bacteria triples, again, I don't know how much we started with, but when we divide this C value over, we would get 3 if it's tripling. Whatever you started with, if you have 3 times as much, when you divide this over, you're going to get 3. So 3 equals e to the power k times t, and k is this. So it'll be ln of 2 over 3 times time, and we're solving for the time. So again, ln both sides, that'll get rid of e, that cancels out with the e. And then we're solving for time. So I'm going to multiply over this 3. So multiply over the 3 and then divide by ln of 2. And of course, they use the slantwise fractions bars there, so it's harder to see, but it's 3 ln of 3 over ln of 2. So that one is A. All right, number 5. During a certain epidemic, I wasn't sure if I was going to assign this one because this hits a little close to home this year, but you know, viruses grow exponentially. Right, during a certain epidemic, the number of people that are infected at any time increases at a rate proportional to the number of people infected. All right, that just means that this is exponential. Y equals C e to the KT. If you don't have that many infections, it's not going to grow as rapidly. And then the more you get, the faster it spreads. Right? 1,000 people are infected when the epidemic is first discovered. All right, so C is 1,000. And 1,200 are infected 7 days later. So 1,200 goes in for that Y amount. 7 goes in for time, and we're going to solve for K. So dividing over the 100, that is going to give us 1.2. Or no, it wasn't 100, 1,000. 1,000, that's going to give us 1.2 when we divide that over. Sorry, I forgot a 0 there. Equals e to the 7k. And then we're going to ln both sides. And then we're going to divide by 7. So we're going to type in here ln of 1.2 divided by 7. I'm going to store that. I'm going to write 0.026 on my paper, but I've stored that so I can reuse it. And then they ask us, how many people are infected 12 days after the epidemic starts? We're going to plug in 12 for time. So again, we started with 1,000. It'll be e to the power 0.026 times 12. And just when I type that in, instead of 0.026, I'm going to use the stored value. So we're going to copy and paste that. They rounded to the nearest whole person, so it would be 1,367 people. So they're going to not chop a person into pieces here. So 1,367 people. So that one is C. All right, number 6. This is another one where they didn't use a calculator. See, they left these all just with the LNs. Oh, gosh, I know that's so tiny. Anyway, we're not going to use a calculator for this one. It says during optimal conditions, the rate of change of the population of a certain organism is proportional to the population at that time. Again, that just means we have exponential growth. Right, at time 0, this is initially, the population is 300. So we're going to put in 300 for C. And then at time 24 hours, the population is 1,000. So we're going to put in 1,000 for the amount, 24 hours for the time, and then we're going to solve this. So dividing over the 300, that would give us 10/3. And then ln. And then we're going to divide by 24. So we're going to leave it as ln of 10/3 over 24. Just don't put it in the calculator. And the question, at what time is the population 500? So going back to the original equation, we're going to put in 500 for the amount. So 500 is y, 300 is what we started with, and it's e to the power k times t. So this is k. I'm going to write it as 1/24 ln of 10 thirds, because looking forward, that's how they have it in the answer choice, right? Times t. This is 1/24th ln of 10 thirds times t, and we're going to solve that. I realize it looks like a mess, but you just got to go with it. All right, divide over the 300. That'll give you 5 thirds. And then we're going to ln both sides again to cancel out the e. And then to get time by itself, we're going to divide this over. So it will be ln of 5 thirds over 1/24th ln of 10 thirds, which looks a mess, but it's fine. And again, it's actually less work than typing it in the calculator because you don't have to do any button pushing. It just, it just looks awful. So that one is D. All right, last one. The quantity R in grams of a certain radioactive substance decreases according to the decay model. And let me write that a little bit better. dr dt equals negative 0.05 R. So this is K. That is our K value that they're telling us there. Time is measured in seconds. During an experiment, a scientist determines that the rate of decay of a second substance, which we're going to call quantity S, we're going to compare these two things. We have R and then we have S, is represented by a linear model, ds dt equals -4. Okay, this one's going to be exponential. Says that this one is linear. So when they give us ds dt, this is the slope for the linear model that we're going to have, -4. So this one's going to be our, y equals c e to the kt. That's our exponential. This one's going to be y equals mx plus b because it is linear. We're going to get an equation for each one of them. All right, at time 0, so they gave us the rates. Now they're going to give us the initial conditions. At time 0, r of 0 is 100. So for this one, c is 100. And it says s of 0 is 125. Now for a linear equation, we're going to do, y equals mx plus b. We start with 125. That's our b value in our slope-intercept form. So we're going to write an equation for each of these. This one would be y equals 100 e to the power negative 0.05 t. So again, that one's exponential. This one's y equals mx plus b. So our slope is -4. And then our initial condition, our y-intercept was 125. So this is exponential, this is linear. They had to give you all that information. So it was kind of a paragraph to read through because they had to give you the rate and they had to give you the initial condition for both of them. But they gave you everything you need. We wrote the equations. It says, at what time will we have equal quantities of the substances? All right, what that means is we want to set these equal to each other. So we are going to go to y equals, I'm trying to clear out everything about here. All right, we're going to go to y equals, we're going to put one of them in y1 and one of them in y2. And we're going to see where they intersect. Now, I have my window set to standard, -10 to 10. I know that this y maximum is going to need to be above 125. If this line went up 125, I know that that y maximum is going to need to be bigger than 125. So I'm going to round up to the next 100 and just make that 200. You can start with standard if you want, but nothing's going to show up because the graphs are going to be all the way up here. So I changed that y maximum, like I widened this out so that we can actually see the graphs. There's the exponential one, there's the linear one. Now you can see they intersect here, but I don't want anything on this side because that's all negative time. So I need this intersection that's going to be over here. So I'm going to need to widen out the x maximum as well. So if we go to window, x maximum, let me make that 50. I think that should be far enough. Window, if you're not given a window in the problem, you kind of just need to mess with it until you can see what you need to see. I don't have really specific instructions for that. It's kind of like fiddle with it until you can see what you need. All right, so there's our intersection and our calculator will tell it to us. We're going to go to calculate, which is second choice. Intersect. It's going to ask you first curve, second curve, guess. You pretty much just hit enter for all of those. Just on guess, make sure the cursor's closer to this one instead of that one. It's going to give you whichever one it's closer to. So hit enter for guess, and here's our answer, 23.548. So to recap, we made an equation for each of them, we set them equal, we made the calculator do the intersection, and that answer is C.